Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. I don't know what the title of this lesson is going to be. It depends on what class you're in. But what I do know are our two goals. So let's go ahead and see those. Our first goal is going to be Introduction to Vectors and how to use those in translations. Our second goal is going to be establishing rules for translations on the coordinate plane and writing the translation in component form. That makes it plural. Translations, plural. There we go. All right, so basically, excuse me, let's recap what the prior two lessons were. We were introduced to transformations, which are ways to slide an object, actually rigid transformations, ways to slide an object, spin an object, or flip an object. I feel like I'm TikTok dancing again. But we were introduced to 3 rigid transformations, and the thing about a rigid transformation is after you move the object, it's still the same size and same shape, it's just in a different location. Today's lesson, we're only going to focus on translations, which is the movement of an object. Okay, we're sliding it. And so what we're going to see is we're going to see other ways to represent directions on how to do a translation, and hopefully it makes some sense. So pay close attention to how notation is used. I'm just telling you how to do the same thing basically in 2 different ways. All right. So we previously saw that we can describe translations using a rule. An example would be the point xy maps to x plus 2, y minus 3. So if I had the point, let's say A, and it had the coordinates 5, -6, and I mapped it using this translation, I would add 2 to my x value, so I would get to A prime, which means I've moved. I would have 7 because that's 5 plus 2. I owe you 6, I owe you 3, so that means I owe you 9, right? So we've seen this, okay? And I'm going to show you how this looks in what we call vector form. So we can represent this translation using a vector, which is an arrow that shows direction and magnitude. Magnitude is a very fancy way to say how far. Right, so this is a vector, and it's an arrow, and it's showing you the direction I want you to move. I want you to take what we have, and I want you to go in this direction, and I want it to have this magnitude, or I want it to go this far. This vector is this rule, okay? And let me show you why it's this. We can think of this as slope. Remember, x is horizontal, y is vertical. Oops. So if I want to go from this point to this point, I can make basically a slope triangle. And to go from here to here, I have to rise down 3, and to go from here to here, I have to run 2. So this vector is telling me what I learned about a rule. I'm just telling it to you in a different way. Remember, I'm going to tell you how to do a translation in 2 new ways. So this first way, I'm going to use a picture to tell you how to move. I'm telling you in a picture. So let's look at this example. I want you to translate triangle ABC using vector V. I'm telling you how to move right here. This tells you how to move. Oh, email. So this vector is telling me that I'm going to move over how far? 1, 2, 3, 4. I'm going to go 4 to the right, and then it's telling me to go up 1, 2. It's telling me to go up 2. So I'm going to move every point 4 to the right and up 2, and I will have my image. Remember, this guy right here, this is called my pre-image. And I'm going to map it to my image. So point A goes over 4, so it goes 1, 2, 3, 4. So I'm here now for A, and I go up 1, 2. So now I'm here for A prime. This is my A prime. Point B goes over 4, 1, 2, 3, 4. Okay, I'm here for B, and from here I go up 1, 2, 1, 2. Now I'm here at B. which is now my B prime, and C goes over 4, 1, 2, 3, 4, and from here I go up 2, 1, 2. All right. C prime, there's my triangle. All right. So I've used this vector to move this, and what I'd also like to show you is if I draw this vector from A to A prime, B to B prime, and C to C prime, you'll see that I have the same vector repeating itself 3 times in the same direction at the same length. Okay, so I've slid the triangle. Now there's a couple more vocabulary words I'd like to talk about. Point A, B, and C, those are called initial points. Points A, B, and C are initial points. Let me write that better. I'm having a really hard time today. Okay. And points, come on, you can do this. Points A prime, B prime, and C prime are what we call terminal, which is kind of a morbid way, terminal, which is a morbid way to say end, right? Okay, so we begin at the initial points, we end at the terminal points, and I don't like that they call where you fly out of terminals. Anyway, that's a personal thing. So I'm going to go ahead and erase this. I'm going to set up for the second goal. And again, remember, I'm just trying to show you another way to say a rule. And I'm doing it using a picture. All right, so let me clean everything off, set up the second goal, and I'll be back. I'm back. Let's move on to the second goal. And let's review what the second goal was. Establishing rules for translations on the coordinate plane and writing the translation in component form. Sounds super complicated, but I promise you it's actually much simpler than that. Let's spend a little bit of time reviewing here. Going to the right is positive, or is a positive x value. Going to the left is a negative x value. Going up is a positive y value, and going down is a negative y value. So I have an example that's going to test to see if we understand what the following rule is going to do to point B. If I tell you the rule, xy maps to x minus 3, comma, y plus 4, what does that do to point B? So somehow, some way, these concepts are related to this. I'll give you a second to think about it. And if you want to hit pause, and then jump back in. You should have hit pause by now and hit play. So what this rule is going to do to point B, well, I have a negative, so I'm going to move to the left. We're going to move to the left 3. And I have a positive with a y, so I'm going to move up 4. Move left 3 and up 4. Okay, so I want to now formalize the rules for translations on the coordinate plane. And we have 4 moves that we can do. Right, left, up, or down. So if I want to move A units to the right, xy is going to map to x plus a, comma, y. And again, this is how I move to the right. If I want to move A units to the left, x comma y maps to x minus a comma y. So this is how I say I'm moving left. If I want to move B units up, x comma y maps to, now remember, up is a y concept, x comma y maps to x comma y plus b. And if I want to move B units down, x comma y maps to x comma y minus b. So these are the 4 basic rules, and you can kind of see right here. So back to this, x comma y maps to x minus 3, y plus 4. I'm moving left 3 and up 4. Okay, we can combine them in this as well, right? They don't have to be strictly left, strictly right, strictly up, or strictly down. TikTok dancing again. Stop that. All right. Let's move on. We have 3 ways to represent a translation. Okay, and so like I said, the second goal sounded kind of complicated, but it's going to be actually what I believe to be simple. So I can represent a translation as a rule. This is what we've seen. X comma y maps to x minus 2 comma y minus 3. So I'm going down 2 and left 3, right? Let me try that again. I'm going left 2 and down 3. I'm going to learn the rules. So this is us going left 2 and down 3. All right, so I can I can express the translation as a rule. I can talk about it as a vector, where I draw an arrow that has a length, which is a magnitude of how far I want you to move. So this vector is actually the same as this rule. I want you to go down 3, 1, 2, 3, and I want you to go to the left 2. So this vector is actually saying the same thing as a rule. Now, I can say this in a third way, and this is the second part of our first goal, writing the translation in component form. Now, when we use component form, we're going to use, I don't know what these are called. They're not parentheses. I don't know what they're called. But we're going to use this form of parentheses. And when I see this, it tells me what I'm doing. This tells me, because this is in the x position, that I'm going to go left 2, and I'm going to go down 3. And I know I'm going down 3 because that's in the y position. So with this, I don't tell you how the point maps to its new location. I just tell you how you're moving. That's what the component form does. It just says how I move. I hope I can fit this. Okay, just tells us how to move. I don't know why I made that L look like a T. Now, I'm on purpose not going over examples. For this assignment, I'm hoping that you can use the tools that I taught you in order to answer the questions you're going to be asked. Maybe you move an object using the rule, the vector, or the component form. Or maybe you have to write a rule or draw a vector or write it in a component form that describes how the pre-image maps to the image. So somehow, some way, the skills in this lesson will be enough to answer all the questions on the homework. If there are further questions, I will go over them with you. So I'm going to go ahead and end the lesson here. Again, I hope everyone is doing all right out there. Have a good day, everybody. Bye-bye.